Hello everybody, I'm Mark Tewksbury, your host for this program. Our goal is to reveal the methods and materials that turn out the everyday products you see around you. If you thought you knew something about these items, you might be in for some surprises. There's a whole world of things waiting for us to discover here on How It's Made. On today's program, compact discs, cheese, Pantihoses, and fluorescent tubes. Some people are drawn to those shiny cars with that special metallic finish. Metallic paint actually contains metal particles, most often aluminum. Powdered metal is combined with paint paste to provide color, brilliance, and that metallic effect. The larger the particles, the greater the effect. Millions of data bits representing numbers, words, music, and drawings, today all available on compact disc. The best part for me is it's so user-friendly. Compact discs are copies made from an original glass master disc. A thin plate of glass is first placed in this unit, which brushes the surface to perfectly clean it. The machine starts up. Cleaning is done with deionized water and a small goat hair brush. The excess water is eliminated by the rapid rotation of the disc. The disc then goes into this surface analyzer, where a laser beam inspects the cleanliness of the surface. At this stage, two chemicals are applied, a primer and a photoresistant coating. This operation is done at a temperature of 21 degrees centigrade and lasts 3 minutes. The disc is delicately retrieved from the apparatus. Then the photoresistant coating dries in an oven for 30 minutes. This developer has two spouts. One applies deionized water and the other sprays a solution to develop the data etched on the glass. The information is now engraved on the disc. The disc is placed in this metal coating equipment. The next step consists of applying a thin coating of nickel and vanadium. This electroforming process results in the master from which discs will be made. The etched glass is immersed in a chemical solution for 70 minutes. Then the plated piece is removed, thus obtaining a die. This die is sent off for finishing. It is stamped out into the desired shape. The excess material is later recuperated for recycling. Following on, the compact discs will be fabricated from this master unit. Here we clearly see the stamping out technique. The master is taken out. A technician peels off the film, which protected the data etched onto the die. Following a visual inspection, the die is sent to the pressing department. The die is delicately installed in the mold, which will form compact discs. Discs are made from a very special plastic called polycarbonate. The mold is closed and liquid polycarbonate is injected into the die. It comes out as a small, hard, translucent disc. It is now ready to be metal coated so that it can be read by a compact disc reader. A robotic arm lifts the disc from the mold and places it on these supports. This metallizing process is extremely short and very simple, taking but a second. It consists of covering the plastic disc with a very thin coating of aluminum. Here we see the inside of the mold, where the aluminum coating is applied. In this facility, almost everything is automated. This allows for the production of over 100,000 compact discs per day. Protecting the surface of the disc is essential, so a coat of varnish is applied, which also allows silk screening to stick well to it. Ultraviolet lamps very quickly dry the varnish. And here in the pressing room, they apply the label. This step is also very fast since the machine prints 70 discs in 60 seconds. Once the silk screening is completed, the finished discs leave for packaging. Pizza, lasagna, sprinkled on a salad. Many people like a little cheese in their life. The story of making cheese is one involving milk, curds, and whey. Like all cheeses, mozzarella starts from milk. To assure good milk quality, the interior and exterior of tank trucks transporting milk must be washed after being emptied. A tank such as this one can carry an average of 30,000 liters of raw milk at a temperature of 3 or 4 degrees centigrade. Raw milk destined for cheese making contains 3.8% fats and 3.3% proteins. They store the milk and whey, a milk byproduct, in these immense silos, each with a capacity of 225,000 liters. This milk separator extracts surplus cream to adjust the percentage of fat according to the type of cheese to be made. Fabrication begins with this tank, which feeds the pasteurizer. Pasteurization sterilizes beverages which can easily ferment. Milk samples are drawn off to precisely determine their milk fat and protein content. Tests are carried out in this laboratory where they impose controls. These test tubes contain milk samples which will undergo microbiological analysis. Milk quality must be impeccable. This is a curdler with a 25,000 liter capacity into which milk and other essential ingredients for making mozzarella are introduced, such as the enzyme rennet that curdles the milk. This mix must be well stirred and cooked. The agitators are used to cut the whey into little lumps. This step takes about 30 minutes. The temperature of the tanks depends on the type of cheese they're making. Agitators continue stirring the milk. Once cooking is done, the whey is pumped onto tables to be drained. It stays there for about 25 minutes. The solid and the liquid are now well separated. The liquid we see draining is called lactose serum. The lactose serum will be concentrated and transformed into milk byproducts. The water has been almost entirely extracted and the cheese particles are now sufficiently dry. This large automated blade then moves cheese particles towards the next step. That is, toward the molder. In the molder, the cheese is cut up before being carried to the cooker, the final processing step. It appears that this mozzarella has just the right texture. The cheese finally arrives at the molder, which will give it the proper shape. Each mold has a 2.5 kilo capacity and is rectangular. Brine, a salt solution, serves to cool as well as to salt the cheese blocks. The blocks are unmolded and fall into a brine tank. Following on, the cheese blocks will remain in another brine solution for a while. They are then carried by a conveyor towards another tank, where they will be immersed for 4 to 10 hours at a temperature of 2 degrees centigrade. Sprays of brine remove the foam which forms at the surface of the tank. The 30,000 liters of milk that we saw coming in by truck at the beginning have enabled them to produce some 1,400 blocks of cheese in only 8 to 12 hours. The cheese blocks are finally vacuum packed, ready for shipment. Women appreciate that pantyhose come in a variety of colors, shears, and textures. Us guys, we appreciate them too. Maybe for different reasons. Making a nylon stocking takes only a few minutes. However, it's a complex operation that involves the knitting of 5 to 8 threads as fine as a hair. The threads, usually nylon and spandex, strong and elastic, are used. Sometimes polyester or cotton are added. The knitting machine goes into action. This one fashions a tube for sheer stockings in 90 seconds. In 3 minutes, it makes a tube for tights. Its speed is adjusted according to the product being made, varying between 750 and 1,200 revolutions per minute. Once the tube is knitted, it is sucked up and lands in a bag where it will be inspected. More than 500 machines share the work, each making a model that is specific for it. The two ends must now be joined. This automated machine assembles the two tubes together to form the pantyhose. Then a scissors cut the pantyhose, a necessary step in production of a pair. This opening is enlarged to allow for sewing, which will join the two tubes at the point of the panty. The label with the size or brand name is already sewn in place in just 10 seconds by this robotic machine. At this pace, it sews on 4,800 labels in 8 hours. Installing a gusset requires some preparation. A scissors makes a hole at the joining point. Then the stocking is turned inside out by suction so that certain stitching can be done on the inside. Thus, these stitches will be less visible. Now the foot must be sewn. This robotic machine places the foot in position. Then a sewing machine makes stitches at the same time that it cuts away excess material. This step requires only 10 seconds. Then the pantyhose is turned right side out, again using suction. Everything is ready for installation of the gusset. The pantyhose is placed in a tub and taken to this department. The stocking is again suctioned and placed on a gusset machine by the operator. This method assures that the gusset will be installed well-centered without a pleat. Putting in the gusset is the final operation in the process. A pre-cut piece of cotton is slid into the space reserved for the gusset and automatically sewn in. Only aesthetic touches remain, such as adding a little color to the pantyhose. They're placed in this machine, which has a large drum with 4 compartments and a 45-kilo capacity. The pantyhose are washed in soapy water, then immersed in dye. Temperature climbs gradually to 93 degrees centigrade. After a 5-minute rinsing cycle, a softener is added. This all takes 2.5 hours. Once dried, they proceed to inspection. The pantyhose is placed onto a form which stretches it to allow inspecting for any imperfection. If all is well, the pantyhose is transferred onto another metal form where it will be pressed. The pantyhose is positioned, guided by a magic eye. The pantyhose is then carried toward a steam room, remaining there for 2.5 seconds before being dried in 7.5 seconds at 140 degrees. They fold and pack 420 pantyhose per hour and make 180,000 pairs per day. Besides providing light as cool white, or with a rose-toned color, fluorescent tubing is also known as being a very low energy consumer, which is probably why we find it in so many homes, factories, and offices. Once the only source of light was the flame of fire in the forms of torch, candle, and oil lamp. It remained so right up until the 19th century, when gaslight made its first appearance around 1840. Almost 40 years later, Thomas Edison invented his famous incandescent light bulb. In 1909, the Frenchman Georges Claude developed the fluorescent tube, a light remaining unaltered to this very day. Did you know that mercury permits us to see in the dark? The production of fluorescent lamps is highly complex. The fabrication process starts with glass tubes that have been meticulously cleaned with warm water to remove dirt and impurities. Then the tubes have to be specifically shaped with a folder shaper. They're heated for 30 seconds, then quickly curved using a template. This automated machine can bend 14 tubes a minute. The bent tubes go into the coating chamber, where a thin coat of phosphorus is applied to their inner surfaces. It's phosphorus which produces light by transforming ultraviolet generated by the ionization of mercury. Then the surplus phosphorus is removed from the ends of the tube to facilitate sealing them. They now move to the electrical components. The cathode mount is made in this auto mount. Here they make the wire carrying current from the mount. The wire carrying the current is shaped. And here the wire is heated. This prepares it for the next step because it's essential to prevent the cathode coating from spreading to the prongs. The filaments are inserted into their mounts. The emissive substance plays a crucial role. When heated, it emits electrons which participate in producing light. The emissive substance is actually this liquid, and the wiring mount is transferred from the auto mount to the sealing machine. At this stage, the wiring mount and the glass tube are finally joined. Sealing is done at a very high temperature. One important step remains. This is where the glass tube is emptied of air and filled with gas. This machine also decarbonizes the tube and introduces the drop of mercury, essential for producing light. Once the very tiny drop of mercury is injected into the tube, the production process for making the fluorescent lamp is now nearing completion. But one step still remains. This threader positions the wires for insertion of the tube cap, which serves to establish electrical contact. The tube cap is placed into position in preparation for sealing. The cap must not only be securely attached, but also installed in a watertight way to eliminate any risk of leaking. The capper permanently seals the cap onto the tube, and it's all finished. Each lamp is tested on a large testing wheel to verify its quality and good functioning. And once the meticulous inspection is over, the fluorescent lamps are carried to the packaging department. A robotic machine handles the lamps and places them into the packages. The glass tubes have now become fluorescent lamps. If a picture's worth 1,000 words, I hope what you saw today speaks for itself. Our goal was to show you behind the scenes the manufacturing of everyday items. I'm Mark Tewksbury. See you next time on How It's Made.